So gas properties. So first, it can be easily compressed. It uniformly fills any container it mixes with other gas completely. So it mixes completely with any other gas and what else? It exerts pressure on its surroundings. So these are gas properties. And now we are going to start studying gas laws. So gas law is mathematical relationship. So we are going to talk about gas laws. Alright, let's move on to next slide. There are four variables of the gases, like pressure. Pressure is the first one that affects behavior of gases. Volume, temperature, and moles, number of moles of gases. These are four variables. Alright. Now, mathematical relationship. Among these variables, and properties of gases you discovered. When you define those relationships, you can see properties of gases. Can be discovered. So we'll see what kind of properties. So we'll start with Boyle's law. Okay. Now remember, we talk about four variables. These ones, right? Pressure, volume, temperature, and moles. So what Robert Boyle's, or we can call Boyle's law right now. Boyle's law. This scientist, he manipulated two variables. He said, I'm going to manipulate two variables, increase and decrease, pressure and volume. And he kept this one constant. He said, this temperature I'm going to keep it constant. That means there is no effect on temperature. Alright? So when he did it, and let's say what he did. So this is a container, okay, it's like cylinder and piston assembly. In this cylinder he put some gas molecules, the number of the moles of gas inside, and then he measured pressure, pressure 2 atmosphere, and the volume 2 liter, the volume of the gas 2 liter. Okay, and then in other conditions, what he did, the same container, same everything, but he pressurized more on this gas. So what happened? When he doubled the pressure, 4 atmosphere, right, pushes forward, this piston is like sliding inside the cylinder, so it pushes forward, so pressure is double. What happened to the volume of the gas? It becomes half 1 liter, for example, right? And what he did, temperature, he said, let's see, it is 273 Kelvin, 273 Kelvin. So temperature is constant. So he found relationship between pressure and volume. He said pressure increase, volume decrease, and pressure decrease, volume increase. When you expand, volume increase. So that relationship is indirect relationship. Indirect means one increase, other decrease. So they are inversely related. Inversely related. I'm going to go to next page. So based on this, he defined relationship in mathematical form. So let me go to next page. He said, yes, pressure and volume are inversely related, or you can say indirect relationship. And that mathematical he defined P V equals K, or P equals K over V, or PV equals K. Let's define this way, PV equals K. Okay? So, where K is a constant, K is constant, right? And temperature is also constant. So, it's specific temperature, T constant. Now, for two conditions, let's say P1, V1 equals P2, V2. For two conditions, he compared and he gave this definition. Alright, so that's how he defined relationship between pressure and volume. And then when he plot graphically, usually whenever there is a direct relationship, it gives straight line, right, between two variables. But when there is inverse relationship, what kinds of graph you get? If it is indirect relationship, let's say if it is pressure and volume, you get kind of parabolic graph, right? Because what happened, if pressure increase, let's say at this point pressure is 4 but volume is 1, right? When you extrapolate, when you do that, you get 1 liter. Here volume is 4 liter, but then pressure is what? 1 atmosphere, right? So that's the graph of Boyle's law. Now let's work on one simple example of Boyle's law. Okay, so let's go to next slide. Alright. Chlorine gas occupies a volume of 1.2 liters at 720 torr pressure. What volume will it occupy at 1 atmosphere pressure? Okay, so in this one you have, there is a direct, like volume is given and pressure is given, 720 torr, and then we need to find out at 1 atmosphere what will be the volume. So let's consider this one is V1, this one is T1, and this is a T2, and we need to find out V2, right? Now, we know that 1 atmosphere equals 760 torr. That's the one. So we can convert directly that, okay, that's going to be 760 torr. Now we have this equation P1V1 equals P2V2. We know that V2 we need to find, so we organize V2 equals P1V1 over P2. Now V1 we have 1.2 liter, P1 we have 760 torr, divide by P2, which is, no, 720 torr, I'm sorry, that's the 720 torr, and 760 torr. And when you do calculation, these torr cancel and you get in liter. When you calculate, you get 1.1 liters. So you can see, you can say that 1.1 liter will occupy if atmosphere is 1 atmosphere.